my gosh. Okay, I'm sorry. Yeah, like first I will go over some key reaction, and then we will go through some main mechanisms. So for the chapter 21, yeah, it is carbolic acid derivatives. So you should know those things. This is nitrile ester.
What is the world's most irritating beeping? Does that turn off?
What?
The beeping.
This one?
Yeah.
Yeah, this is turn. This is turn on, so it can catch the whole things into the computer. And this is an acid chloride. So first we are talking about the ester. So how to synthesize the ester? So the first one is the Fischer esterification. So basically, just use the acid plus alcohol. So on the acid condition, so there is water left, which is this part. So it will give the ester plus water. And the second way to do that is to treat the acid with the SO2, and it will become the acid chloride. And then you treat with some alcohol, so it will become the So next is acid and this is anhydride. So to make anhydride, we just basically use 2 acid. So you just remove the water. So you need to use the phosphorus oxide. So you can make the great. This is a material we covered in class. Yeah, I just give you some summary, so don't be so confused. Taking exam. So next is the nitro. So this reaction is important. So this is halide. Treat with the cyanide. So you can get the nitrile, and at this point, if you treat with the lithium aluminum hydride, you will get amine. If you treat with the water, you will get the acid because it's hydroxide. You will get acid. So also another reaction is if you treat the acid also with vessel CO2, you can get the acid chloride. Now if we treat with the amine, you will get amine. If we treat this amine with phosphorus oxide, now you can get the nitrite again. So
It's not NH2 or NH3.
a mixture of them. There. Oh, this is NH2. Yeah, NH2. So, and then we can talk about some reaction. Reaction about ester. So, the ester, here's my hand. The ester, if you treat with acid, you can get the acid. But acid, so this is alcohol. Sorry. And if you treat with the lithium aluminum hydride, which will reduction to the alcohol. Nice, lithium. Snowy oats. And this is the reaction. And we talk about reaction of anhydride. So it's Fischer-Crafts reaction, or something like Fischer-Crafts reaction. We have the benzene here. You treat with something like this. You can get the right, and you treat with something like this. You can get this. So okay. Did you finish copying this part? You want the picture? fix this part. So now it's some reaction. Acid, chloride. Acid, chloride. So basically, there are those really important ones. So first, if you treat with the benzene and AlCO3 and acid, you can get this Fischer-Tropsch reaction. If you treat it with the ammonia, you can get ammonia. If you treat with alcohol, you can get the ester. If you treat with water, you can get the acid. And if you treat with something called lithium tributyl aluminum hydride, which is this reagent, you can get the aldehyde. Reaction of nitrile. So nitrile treat with the Grenier reagent. You can get the cake. Treat with the acid. You can get the carbonic acid. Treat with the reduction reagent. You can reduce to the like what I said before. So I think those are the main reactions you cover in the lecture. Do you have any question about those reactions? Because I know in your exam you have reaction part and the mechanism part. Right? No?
Yeah, we do.
Yeah, just directly write down the product. Yeah, so I think those are important. You should know. Okay. So now we can talk about some mechanism. So how many mechanisms you're supposed to know? Because from my notes, like we have 6 or 7. Yeah. Yeah, I will talk of
It would be good to get to chapter 22.
what?
It would be good to get to chapter 22.
22, 20, 22, 22, 21, 22, or, oh, I know 22, those are complicated. Like, yeah, I will go through that, but first I will see the first mechanism is, okay, is an enamine batch. Which nutrient you can give this. Do you want me to go through the whole mechanism, or we can do that in your home, at home?
Go through it.
Okay. So this one. So first. Okay. So first, this amine. Okay. This is the non-pair electrons on the nitrogen will attack the atom. So you can generate something like. And this is important because I had it in mind. Okay. We'll just talk about the mechanism. Okay. So yeah, could you please send me the numbers? You will get like this structure with the negative charge on the oxygen and positive charge on the nitrogen. And then, because this is in acidic condition, so the hydrogen will proton to the hydrogen here will proton to get this structure, and it will keep. Yes, I should. Please. And then one side just become to the water. So water is a living group. So the non-pair here will delocalize and kick out the water. And then you get this structure. I'm sorry, I made a mistake here. this nitrogen is supposed to have a hydrogen attached here, and then it just go here. So you won't have the positive charge here. So, and the hydrogen go here, double bond just go here, and you will get this structure. This structure is what we call the A domain. So, and this non-paired electron will attack this double bond, and then it will attack this halide. So pick out the bromine. You get this. And the water then will attack this double bond to delocalize this double bond here. So you get structure like this down here on the nitrogen will attack this hydrogen on the water. Eventually, what we pick up and get the final product here. So like this purine, I mean, is a good base to do the alpha substitution on the ketone. And the second mechanism is the aldo condensation, which you have the ketone here plus ketone here. So somehow you lose the water, lose 2 water, so you can get the double bond and the ketone. So you have to you have 2 choices. One is base catalyzed, one is acid catalyzed. So this and the acid. So the base cat, so it basically the base will decode the alpha hydrogen first. And the acid cat is the oxygen carbonate. This oxygen carbonate or the protein. The acid. So this is only difference for those two base and acid. I'm not sure to remember or can you recall about this part? Yeah, you're not going to do that, right? How about you? How about this? About this? I don't know. Yeah. Okay. Did you finish? Did you finish this part?
Not quite.
Cool. So I'll go to another. The next is in chapter 22. First is the place and ester condensation. Place and ester condensation, which is to ester treat with the salt. So you will get this product. So first, this is alpha carbon hydrogen can be deprotoned by this base. And you will get the double bond here, active charge, and then the double bond will attack the other ester here. And keep out the OUT. So this is how you get the final product. And the next mechanism you're supposed to do is the acetic ester, which will continue from this product. if you continue to treat this one with this and the Rx, so eventually you will get you will get this book.
It's the arrow around the oxygen.
Which one? The arrow? Oh, maybe this one?
No.
Here. This is not really formal, but yeah, this is an arrow around. It's supposed to be this first. I just attack here so the double one go to the upstream first, and then you will get something like this and this. Now here we'll go back to here and take out those two. This is 2 steps. And for this step, it's just for this mechanism, the R carbon hydrogen will deploy by the base. Okay, and go here, and then you get double bond. So now here we'll go back to here, and this double bond will attack Rx of the X. And now you are got this structure. As the OET is already good medium time, so the water will attack here and take out this OET, and you will get here. Once you treat with this one, hydrogen will be frozen and having the acid. But this must be in the acidic reaction here. Acid here. However, if you have acid near with the ketone, this acid will be really unstable. So now this atom will attack this hydrogen. Go here, go here. So you will lose one water and one CO2, carbon dioxide, and then you will get your structure like after we organize, you will get the final. Product. This structure is very unstable, so the acid this part will decompose to water and carbon dioxide. So I think this is the most difficult part for me.
Where's the water?
Here. Is this oxygen attached to here? Oh, there's no water, sorry, my bad. Just only oxygen, carbon dioxide.
Yeah.
Oh. Wait, so this is acidic ester condensation. This is the
Yeah. Does ester condensation need an acidic workup?
If it, you mean the first one or
No.
the second one, right? They need the acid to work up. Basically, usually, yeah, they need the base first to do the reaction, then use the acid to work up. And then I will talk about the mononic mononic ester condensation. What?
And the electrons from the oxygen in that box that those actually come from the double bond.
Not really, because it's acid reaction and the acid condensation. So actually, they do have non-pair electrons.
Right.
So
You can't form that other bond unless you do get rid of the double bond.
you can do that because this is acidic reaction. Do you remember like when you do the anode condensation in the acid grad?
No, right, look. You're forming a double bond on the carbon adjacent to the oxygen.
Oh, you mean this?
So you can't.
Here?
No.
You mean here?
You can't keep that double bond on the oxygen if you're forming that double bond on the carbon.
Oh, yeah.
So is it?
At least.
Okay. Is there on that oxygen then?
Now? Great. Because what I want to see is which molecules. So there's no positive charge here.
Why does this do?
So the number 5 will be the online ester, which you can do some comparison to the acetic ester.
Oh, one question about the answer.
Mm-hmm.
Can it be any alkyl halide, or does it need to be a primary alkyl halide? Because when we talked about it in class, he used a primary one, but I'm not sure if that's actually necessary.
If it is primary, it will be SN2 reaction, right? Just kick it out. And primary, secondary is okay. Tertiary, it will be difficult to do the reaction. It only I think the only effect is you have the low yield of the reaction, but I don't think it will give you like the tertiary. But actually, it can be the double. So for the magnetic ester, so you will start from the magnetic ester. So this hydrogen will deprotonify the base first.
What are the reagents for this one?
What?
What are the reagents for this one?
This reagent is the same as this one, exactly the same, which you treat with the salt first, base, acid. You will get it's really similar. And this you will get the structure like this. Now, when you use acid to work up, so the oxygen of the oxygen will attack this hydrogen, and it will get this is alcohol. Ethanol, so it's a good leading group. When you have the water attack this carbonyl group, it will make so you get the same structure like this. When you get protein, you get the two carbonic acid. Like this structure is pretty similar with this one, so it's not stable. So one carbonic acid will become the carbon dioxide. And that. So you will get the final product. Which is the I have questions. So the last mechanism is the Robinson bond, which is ethylene. Robinson annihilation. So it's like hexenol react with this. You will get the product two-way product here. So the same concept. The alpha carbons hydrogen will be broken by the base first. And then you get a structure like this, obviously. And from here go back, and this will attack the double one here. With this structure. Then you will get O minus here. And this O minus. Some pair will go back to the double bond, and double bond will attack the water. The hydrogen will water. So you'll get this structure. So, and now, this is still the carbon hydrogen will decode again by the base. And this double bond will have this upstream carbonyl group. And now you can get a structure like this with the O minus here. And the O minus obviously will proton. And it will become alcohol because this is in the basic condition, so it will elimination to form a double bond. This is O minus.
Question about the tester. In that first box step, how did you lose the extra hydrogens? Off them off.
This one?
And from the previous step to
How
that.
did you lose the extra hydrogen?
Yeah.
You just directly
Right.
deep proton because this is oxygen has a positive charge. So when you deep proton, the hydrogen will become a neutral charge. And yeah, that's almost all. And maybe for your practice, there are two reactions about the Robinson animation. When you have something like this, you react with this. So now you will form three rings. If you have something like this, you will react with the UD. Like, do you have?
And from the first bond step to the second bond step, the double bond you form just attacks the hydrogen on the second oxygen, right?
Yeah, I just directly use the double bond instead of the oxygen. I mean, this is not for those two. This to this step. I don't think you care a lot about the arrow, the electron fish, the electron move things. But you have to know, like, if you have two carbonic acid together, it's not stable. You have to remove one. Do you like have more confused about 21, 22 chapter?
So I don't keep good track of the mechanism numbers. Are these all the ones that we're supposed to learn?
These are, yeah. Yeah, these are like the most recent ones. We're supposed to learn.
Okay.
Because when I took his class, he told us which mechanism we need to remember. This is what, but for your class, like he hasn't seen me any.
But we don't need like the billion other ones in the book.
Not from the
Yeah,
very
the
beginning.
problem set.
Yeah.
No, I mean from this chapter.
I think it's just the ones we did in class, like these ones.
I don't understand why he
Yeah.
does that.
I also don't understand why we take quizzes on like terms, or like when, yeah.
How we have problems that is about stuff we don't know about.
All we do is like,
We just copy from the solution manual and it's like,
Oh, you have solution manual?
yeah, of course. He knows we have the solution manual.
that's for the problem sets.
Oh, I see.
Yeah, except he keeps assigning from missing pages.
Mm. Oh yeah, you have solution manual in the library.
Oh, you do?
Yeah, there's
Yeah, check it out. You took my dog, right?
Yeah, like 2014.
Did you like
Plus
it?
two. I like him because, to be honest, the exam is really straightforward. If you can remember everything on those, you can get the point.
What do you think is going to be on the exam? That triple A.
Yeah, this will definitely unlike them. I mean, maybe this is not for mechanism, but this is just for like this. Just write down the product here. And also the first mechanism, the amine, amine one.
the NME.
Yeah, one will be. Because I did remember I write down the mechanism for that one. You don't have final exam, right? We have final exam. Some synthesis problem. I think it's just from your practice exam or something. Homework.
Can I ask you a question about one up there? Yeah, the second one. Where would the like if for these ones, like I mean, if you were to do that problem in a full mechanism, where would the the methyl group be in there?
Here,
Like,
there's no method.
but like if you
Oh, here. It will be here. It will be here. It will be here. Because actually, this one have the this is because this is cyclohexane. No, it has two alpha carbon, right? And it may proton dioxide or this side. It can become if you have the methyl group here, it will proton the hydrogen with the methyl group. This one, not this one. 'Cause yeah.
I thought it was the opposite.
No, it's this way. Cause if you go like this way, you remember the
Oh,
double
yes,
bond is
yes.
more substitute
Yeah.
one to form the double bond.
That's the answer to every question. Yes.
Yeah.
Residence substitution.
Mm-hmm.
So anyway,
And then it just continues.
Yeah, continue with the same.
Okay.
can you send us those?
Notes.
Yeah.
Notes.
No, I mean like going through your phone.
Oh, you mean my notes? Oh, you mean this?
Or both. I mean they're the same.
I mean, you can take picture of my notes if you want. Cause I don't think like I can send you because this is not mine. It's Alex, probably.
No. Okay.
Yeah, you can take picture of my notes.
I'm not sure what's happening in that.
That part?
Yeah.
Okay. Finish. Like, okay, here. It's from the exam 4. Exam 4 here. Here. For the reaction thing. So, this will become. O minus here and double bond here. And O minus will attack the hydrogen here from the water and you get. Oh, sorry, my bad. Actually, it's the double bond will attack the hydrogen here. That's all. That's all.
Do you have any problems that weren't exactly from the notes? Any tricky problems that you remember? Because I don't think you changed it, to be honest.
But we never get the exam back.
But do you remember it?
No, it's 1 year ago, almost 2 years. I can't remember. But I can remember the synthesis one. I only remember the reaction one. In your exam 3, were you tested the weighted reaction?
Yeah.
Okay, so that's really important. And how about this reaction? Have you been tested?
Exam 3, no.
No? Okay, so you probably need to remember this one. 2 butyl lithium, you will get So this is what I mistake in the beginning. I can't do it. It's beautiful.
Okay.
So it means it can be. So now we'll come to method.
What happens at the end of the Robinson reaction?
What? Sorry,
The last step.
the last step.
Yeah.
Oh, because this is OH and the
Yeah.
so it's just elimination from here.
What would be the exact mechanism for it? 'Cause he always shows those steps.
You mean from in here?
Yeah.
Okay, so
Would it just abstract a proton from water and then leave?
yeah.
Wait, but
No, it
Where do
will
you-
attract the. Actually, it's just proton this proton here.
okay.
Sweet. And if you don't have pressure.
So what is it? Usually I look before.
Thank you. You're welcome.